All right, so the enabler for accelerated bioprocess R&D. How do we use SiLA at our chair, and what were the benefits? Like, what is our story? So first of all, my name is Lukas Bromig. I work as a PhD student at the Technical University of Munich at the Institute of Biochemical Engineering. What we do is bioprocess engineering. We do bioprocess optimizations, scale up, scale down experiments, the sort. And the project that I've been working on since May 2019 was the Digitization in Industrial Biotechnology project, which is a BMBF funded joint national research project with the research center in Jülich and Hanover, which do the phenotypization ahead of us and the downstream processing that comes after us in the entire chain of bioprocess development. When this all started, we were basically given a lab, a brand new lab with lots of equipment, but no software, no interfaces, nothing. So we were tasked with, well, somehow making that all digital and automated so that we can speed up our process development. So we had about 8, 9 devices. We had no software whatsoever except, well, the vendor software that was focused on that particular device. But if you want to hook up these devices so that they work together, well, you can, well, in industry, I guess, just go to the vendor and ask them to do that integration for you. At universities, that usually is not the case because you're on a very low budget, and if things weren't budgeted ahead of time, you're not going to get the money afterwards. And on top of that, those setups change. Not maybe every week, but every month, but definitely every year. So you always have to keep things flexible. And if you have fixed integrations into a certain software, well, that integration might have been for nothing the year after, or if another PhD student comes around with a new software and so on. So our problem was that we had so many closed source solutions, so many add-on solutions, like a microplate reader with its software, a pipetting robot with its software, a bioreactor system with its own software, a flow meter, off-gas analysis. They all had their own software. But now if you want to hook them up, if you want to use them all as one, and automate your workflow, well, it's difficult. And that's why we turned to SiLA to basically create this service infrastructure, this service layer. So the idea behind SiLA is that all these devices become a service in your lab that you can just access. So you don't have to go through a specific desktop app. You don't have to run around your lab or go from the office downstairs to do something at a specific computer that is set up there for that device. Now you want to be more flexible, and if you want to change the software that you use for your processes, for your control, or if you just want to use scripts, you always want to access this infrastructure level at the bottom, and SiLA enables us to do that, to keep things flexible, so that one day we integrate this parallel bioreactor system with our pipetting robot. The next week we integrate it with some auto-sampler and a peristaltic pump. So that is the reason why SiLA was very important for us, and why we spent almost like half a year to a year in the beginning to just set up the infrastructure for what we were then supposed to do, which is figure out new processes, speed up the entire research in general. Another small but valuable thing is that we also were able to upgrade lots of legacy devices that didn't really have digital interfaces at all to begin with. We usually do that with low-cost Raspberry Pis that we just install a SiLA driver on. And there's also a nice paper from our colleagues in Hanover where they basically describe on how to do that quite easily. So some of the examples that we've used it then for was at the very beginning. The first study was basically automated protein expression studies, where we used a DASCA parallel bioreactor system, peristaltic pumps, a pipetting robot from Hamilton, sadly not taken, because if they had some sort of SiLA interface, it would have been much easier. And on this pipetting deck, we had a 48 times bioreactor on the milliliter scale with specifically fitted sensors that measure DO and pH. So we had about 7, 8 different devices that all had to communicate, because at a certain time we used those larger scale bioreactors to produce biomass, and at a certain time we want to transfer that onto the pipetting robot deck, distribute it between all the 48 different small scale bioreactors, and then do induction experiments and check how much protein is being generated, and measure protein concentration and so on. So ideally, we want to start that process on Monday in the liter system, and then get back on Friday, clean everything up, and have the data wherever we want it. Yeah, and we use SiLA for that to orchestrate all this, and orchestrate it with Python scripts. So this was the first use case, and then we had several others. The most recent one is automated adaptive laboratory evolution, where we also use a reactor system and several periphery devices, pumps, balancers, and so on, where we basically empty a reactor time after time after time, and in this way replace the manual passaging that is usually done in Erlenmeyer flasks. And the nice thing about it is that we could do the same thing and do the setup within days, because we already had all the infrastructure there. So we could recycle our SiLA driver for the dust-skip parallel bioreactor system. We could recycle the peristaltic pumps, the drivers. So we didn't have to spend money on a second integration again. So if we had, in the first place, made some sort of custom solution that somehow integrated the dust-skip with the Venus from the Hamilton pipetting robot, we would not have been able to just switch and move things around as easily as we are now with SiLA. And right now, it's not just our laboratory, well, my laboratory at my university, at my chair, that is using those drivers, but some of my colleagues are starting to use them as well, because, well, they, by chance, have the same peristaltic pump as I do. They have the same blue-berry off-gas analysis. And now they don't have to do their own integrations anymore themselves, because they can just rely on the drivers that I wrote, which saves a lot of time. And since we have a lot of turnover, so usually we stay for 3.5 years, a lot of knowledge is lost. And usually a PhD student has to, well, get that knowledge in as quickly as possible, but they spend a lot of time doing so, and a lot of knowledge is lost in the process because it's not transferred properly. So now with this repository that we have, we can just access those and reuse them over and over again, and just be done with this entire integration hassle. Yeah, so further advantages that we now have is we can access our devices from a single source. So I wrote basically like a laboratory management system called the SiLA Manager, from where we can remote control all our SiLA-enabled devices from wherever we are, which is pretty handy, since most of our experiments run over an extended period of time, over the weekend, overnight. And the longer these experiments run, the less you want something to go wrong. So sometimes you have, I don't know, sleepless nights. I even installed a camera at some point in my lab so I could look at my reactors. I had a Slack bot sending me notifications if things were out of bounds. So I got woken up in the middle of the night telling me something is off. So then I could just log in and adjust the set points, restart a stirrer, start pumping my reactor empty and refilling it again. So I could do that manually as well and intervene in case something went wrong. So that was pretty handy. Furthermore, we built in a scripting environment in Python, so we run our scripts through that as well. So we always know if something failed, we do get some sort of notification and some feedback. And on top of that, it's not just the control part, but with the software that I wrote, enabled by SiLA in a way, it's now possible to do data acquisition without writing a single line of code, because you can just select the device, you can select the feature, the function, and if it's an observable, you just subscribe to it, and it's being stored in a database. And if it's just a command, you can, for example, set an interval at what time it's being polled and do long polling. And then in our case, we set up a database where it's all just being pushed to, and like that, we just have an interface, a dashboard, where we can access all the data from all those different devices, which we previously had to collect running around with USB sticks. So especially for the analysis part afterwards, it's so much nicer, because you just have a whole batch of data and you download at once, and you can immediately import it in Pandas, in Python, in Jupyter, and start your analyses. And you don't have to kind of harmonize those different data sets. Yeah, so that's also an advantage that we have now due to SiLA. So even students that don't know how to code, that don't know how to integrate some device, they can just select it and push the data where they want it. and then download it there as a CSV file, or just directly access it with a client in Python or whatever language they are knowledgeable in. So the good thing about SiLA is that it provides the specification, but to fully leverage it, you need all the tools, not just the reference implementations, but ideally also like other tools like like device management solutions, like the one that I've built. A solution that like shows you how many devices you have, what their current status is, what the logs of the servers are, and so on and so on. Maybe even a tool that supplies you with insights on usage, how often these devices are used, how often certain functions are called. That would be quite handy to have. And yeah, on top of that, what we're currently trying to do is also move all the software we wrote for SiLA completely into the cloud, so that we don't host that on premise anymore, because most of the people that we have, well, they don't really know how to maintain these things, and if something goes wrong, they don't really know how to, and if the disk space runs low, then the data is lost and that sort of thing. So we're currently trying to look at that, and to enable that approach, we also rely on like reliable, robust edge gateways, for example. So we were looking at it half a year or a year ago, and then it didn't work because it wasn't possible with the edge gateway back then, and now we're gonna try again. Yeah, and on top of that, since we're a university, we always need open access, open source access. That's pretty important for us. But the biggest takeaway for us was that it's really important, at least from our perspective, if you want to stay flexible, that you have to decouple your digital infrastructure from your specific softwares like your LIMSs or your ELNs, because if you always make custom integrations into those, then you're going to do those integrations over and over again. Ideally, if everybody supported SiLA, that wouldn't be the case anymore, because you could do those integrations quickly, but at the moment it's not fully there yet, so we kind of like run this approach. Yeah, and apart from that, what are we going to do now? Since I will be done with my work at university by tomorrow. So tomorrow is officially my last day. I'm currently wrapping up all the driver development, the Git repository, the documentation and all that, which by now includes 9 drivers that, well, 7 of them are actively used. And at the moment, I'm also looking at supervising a master thesis project, which is going to take the SiLA2 manager to the cloud, and which will then be hosted as like a software as a service on our institute's premises. And yeah, as of Monday, I will be at UniteLabs, and what we're going to do there, stay tuned. So, thank you very much.